What's up? Back again with another C/Go video. We might be doing a bit of Go. Yes, last video we were learning about function pointers with Go, and I think I was at the third page of the PDF, and I wanted to learn a bit more about it, see how we can play with it. And I'm sorry for a little bit of background disturbance. I'm in an Indian house, so you can't expect to be completely quiet. But I mean that's the least we can do. Right, so we're learning about function pointers, and just to recap, I like to write code. So let's just write a simple C code. This is a simple C code. If I do make A and I run A, nothing happens. Great. Let's say I have a function. Let's say I have int. Let's have a function add, which takes int A, int B, and returns A plus B. Right? Nothing too serious. We have a function add. It takes two integers as an argument and returns an int. Right? And this runs as well. Right? If I say something like printf, um, and if I say add 1 2, and if I run this, if I make it and I run this, I get 3. Great. So this function is somewhere present at some memory location, right? How do I know that? Well, I could do something like rp, and I can just come and print a add itself, and you see this is some hexadecimal location in my laptop where this function is present, right? And so what function pointer does is we initiate a pointer like how we do normally with any variables, which points to this function, and then we can run that function. So how do we point to a function? So we are pointing to a function which returns an int function pointer and takes two ints as a result, and this is equal to add, right? You can also just give normal add as well, but as you can see this will work. And so now if how do I actually run this? Well, I can run this by basically saying dereferencing it, fptr, giving the arguments and just running this, and you see it works, right? This is essentially going to that function, giving those function these two arguments, and that function returns and we get that value back and over here, right? That's so good. Now how can we use this? Kind of interestingly, how can we use this? Also, as you can see, this syntax is kind of weird. You don't kind of like need this syntax. But let's make another function. Let's make something like int add, int subtract, or you can do int mul, int a into this, return a into b, right? So this is another function that we have. And so the thing is, we could okay, so we could have this thing called void. Um, we could have this thing called mystery function, which takes mystery func as which takes in which takes in a mystery func which takes in two arguments, and we then take two arguments of our own, and this could be essentially like mystery func a comma b, right? So now what this thing does is very interesting, is now we can have printf, right? We can have printf and we can call mystery func, and now I can give it the pointer to this function. So I could say add 1 2, and if I run this, say that, I could now just say mul, and it will give me 2, which is great, right? It works. If I go R2 over here, it should give me 4, and as you see it works. So this is a mystery func, because we can just add a function over here and this will run. Or if you like, if you want to be a bit right, you could also run that thing exactly over here. So right, so how can you do that? You can say something like int add m, add m int n, um, right? And now instead of this, I could have something like, so it wants the address there, I can just say Adam, and if I run this, it still works, right? That is great. Now again, writing this thing is kind of lot, so you could use something of type def. You can say type def int um, function pointer int comma int. Now instead of entire this, I could remove this, and I can I can just say over here, I can say fptr, and actually I can name it. So add p, add p is equal to this. This is essentially what we did. We just made a type def, and so this represents this. So this is a function pointer pointing to add. This works. How do I reference this again? As you would print f. So I'm assuming you do something like add p1 2, right? Let's see if this works. It does work. That's great. So this is pretty much the summary of what we learned yesterday, and we are at the third page. So again, using type def. The syntax of function pointers can sometimes be confusing, so we just use a type def statement to make things simpler. Yeah, again, so pretty much this is the thing. So we can define a variable of type pointers as follows. Another example is type int. This can also be very useful in writing functions that return function pointers, such as the following. So yeah. Okay, this is interesting. So normally you write, okay, this is not that tough. So let's see how we can read this. So in order to read this, what this is trying to say is, um, convert returns a function pointer while it itself takes these arguments. It returns, okay, so the way I read this, instead of, like, we learn about the clockwise spiral rule, what this says is this function returns a function pointer that takes two ints as an argument and returns an int, while this function itself, the one running this, takes const char, right? That's what the idea is over here, right? That's what the idea is. And so that's what it's trying to say, which is very shitty way to say this, right? Much easier way of saying this would be something like, this returns an fptr, convert, const char, or you can say char code, while taking all of that variables. Actually, not that, right? Yeah, so what this does is, if code is equal to plus, um, mm, where's this plus, we will just return at some, um, else we will just return at diff. So this is much simpler, and now I can say mystery func is equal to convert, and I'll just give plus, and mystery func, right, essentially that. And if we run this, okay, my bad, it's not sum, it's add. Cool. And this runs, right? If we get anything else, this could be seed multiplies. That's great. um, the above function takes a char as an argument and returns a function pointer of type ptr as defined above, based on if character is plus or minus. Now if we can simplify the convert definition as follows. Yeah, this is much cleaner than whatever this was, right? Yeah, using convert function. So we have this. Also, you can pretty much do ptr pointer if you have a type def, passing function pointers to another function. So now with that in mind, now that we have that, let's say for yeah, so um, let's say we have int, and we say mystery do func. We can take an fptr func pointer, and we can take int v and int a and do something, right? And we can say, right, so this should work, I would assume, right? So do func would pretty much work. So if we say print f, um, uh you do to func add 1 2. It's a very lousy way of doing this, but chalo, theek hai, whatever. um for example, the function void foo, okay, void foo takes in a void star a int n. What this is like, what are you trying to take in? And f type f. Let's takes a function pointer of type f type as an argument. Similarly, we can return a function pointer from a function as follows. The function foo2, so this takes about returns a function pointer of type f type from the function foo. Next, we will look at the important application of function pointers. We do know that Java 5 and C++ standard template library contains constructs to define generic functions. Generic functions are a great programming tool as a programmer needs to write code once for any data type and binds type. Okay, that's the. In other words, we can implement an algorithm in the most general way so that any data type can be used with the function. One of the major benefits of function pointer is that it can be passed to another function as one of the arguments, exactly as we have seen over here. And if I click this, I go over here. That tells us that this the function that it points to will take in two ints and will return an int. Suppose you want to write a function to find how many elements are in an array, not the capacity, but how many places are taken. The array can be an array of ints or arrays of characters or array of any other type. All we need to know is how to find the end of the array. For example, if we have an array of ints that has a centile that is ends with, then we can write a function that returns true when the array element is equal to this. Otherwise, it returns false. It's following int 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 func int star int I, and it returns if okay. The above function returns true for some I. So how do we use this in a function? Okay. That's too big. What about this? This is nah, that's fine. तो उतना भी छोटा नहीं है ना. So I think what they're trying to say is array filled without garbage values until we have minus and I. Right, something like that. What do you mean by that? Wait, let me just clear this, bro. तो मैं गंदा कर दिया हूँ. Sorry. Suppose we build a generic function array length as follows. The purpose of this function is to find the size of the array, not the capacity, regardless of the data. For example, an array of ints may have a centile value, an array of characters may have this null terminator as centile. What do you mean by centile? Okay. For example, an array of ints may have an array of strings or something like end as a. Okay, that's weird. So regardless of the centile, we need to write a function that can find the array length, not the capacity. So we write the function following. So we write the following function array length. The function takes two arguments, any array, okay, and a function pointer that defines centile criteria. We start with the length 0 and continue to apply term function until and return something other than 0. So we have a type def. First of all, we take int, returns an int, array length, points to anything, and we have fn term nth length 0. So while this returns like it's false, we do length plus 1, we return the length. Convince yourself that this function returns the length of the array called with when called with array length int func. Okay, this is the int func. So we just have to give the int func directly. मतलब, right, pretty much I think. But that's easy, right? To be honest. Let's do this. I think that's fun. So let me just get rid of all of this code. Actually, GG. Yeah, let's get rid of that code. Let's start from scratch. So standard IO. Let's make a function over here. It returns 0. Okay, so let's do type def. What is the type def to use? Okay, so int. Okay, so this is our fn. And what do we do? Wait, wait a minute. Before we even do this, um, let's write this code, which is int func, which takes an int star array, right, and takes an I, and if minus 999 return 1, else we can just return 0. Okay, int array length, and so this could be to any array, and then we have fn term length is equal to 0. There's a bit of a wait a minute. Return length over here. What I'm confused over here. Confused. Okay. So yeah, so it's using it as an index also. So while okay, but the thing is, about this is the issue. So we're gonna start it. Okay, let's do something funny. मान के चलते हैं, मतलब कैपेसिटी 10 है, कैपेसिटी 5 मान के चलिए, और 1 2 3 4 -9 ठीक है, ठीक है। अब मैं क्या करूँगा, मैं करूँगा प्रिंट एफ अरे लेंथ, एंड मैं डाल दूँगा अरे इसमें, एंड मैं डाल दूँगा एड्रेस ऑफ इंट फंक, बिकॉज वो उस फंक्शन को कॉल करेगा। प्रॉब्लम क्या है? माय बैड, ऑल्सो सॉरी। ओके, हाँ मतलब ठीक है, बिकॉज ओके, सो लेट्स कास्ट दिस ओवर हियर। ये थोड़ा अलग है। ओके, लेट्स रन दिस बिफोर दिस। इससे पहले क्या होता है? किसको मतलब इसको ओके इसको कास्ट करना है यहाँ पे. ओके मैं समझ गया. आई थिंक मैं समझ गया क्या हो रहा है इधर. ओके फिर से प्रॉब्लम हो गया. क्या इसमें प्रॉब्लम क्या हो रहा है? आई मैं समझ गया प्रॉब्लम क्या है. um that was easy. I'm so dumb यार. 4, yeah, so 1 2 3 4, yeah. Also I don't think we need this. Yeah, I don't think we need that. That was a dumb mistake. But yeah, so pretty much this is our function that we're pointing to. This is array. ये इसको ऐसे भी typecast कर ही देगा इसमें. And then this works. Cool. Exercise. Write a why is this? Write a function stir func as in func that returns true if this is that. I mean sure. Um, so I can do something like int string func jar star s int I if si is equal to this return 1 else return 0. ठीक है. Returns true if we can give more examples of how to write a function stir func as in func that returns true if this is equal to that. We can give more examples of how to use generic functions for doing lots of interesting things. Generally, if you write a sort function, global sort algorithm on an array of integers or something. My only concern is कि, even though this is supposed to be a generic that works with any type, this type of function bind that we're taking, that is fn, has to be of this format. That is, it has to take an pointer to an array. And this is not me saying, this is the actual if I show you what is the fn, right? You see, oh, okay, okay. This is void. Okay. Give me warning. So essentially what this says is fn is a function that takes an int and a void star and returns an int. Technically this is forming int same over here as well. What can you explain the usage of void star in C language? Oh, what, I can do it like this also? In star p. Okay, I don't know what this thing is saying. I'm assuming this is just means the length, right? So we'll have a function called string compare, which takes into string essentially like char star, and so if it's first one is greater than one, if it's not greater than that, for okay, this is weird. Um, the above function can be passed to another new function that can use to compare two strings using just the first character of the string. Now let us suppose that we have an array of any type and we need to sort it using bubble sort algorithm. We will need to send four arguments, again the array of any type. Okay, size, this compare function and the swipe function. We know that this is needed since the way we compare and swipe integers are very much independent. Like they could be very much dependent on the type of the integer. So you have a struct like person, and the way you swipe is that you swipe only the age, something like that. From the way we compare and swipe strings, no matter what data type we have in array, we need to define a generic bubble sort algorithm. First, we will define two type aliases. Okay, let's just carry on. So let's do something like int string compare char star s1 char star s2. If s1 0 is greater than s1 s2 0, we will just return 1. Else if s2 0 is greater than s1 0, will return uh, will return -1. Yeah, and else we will just return 0. Sorry, what am I doing? Okay, so this is pretty much that the way this was implemented. Okay. Yeah, so that makes sense. So we have type def in comp func. Okay, so we have type def int comp func, which takes in gives out an int. Comp func is a function pointer to a function that takes in a void star and two integers. Is this right or they're making a mistake? I don't know. We have swipe func, which wait a minute. If we have a comp func like this, comp func, then why do we need two integers? What? this will be wrong, right? Because okay, we have a swipe func which is void star. Okay, so this is the actual array of whatever type we actually don't really know. This is the length of that array. This is our compare function. This is our swipe function, and so we do CP, and we do so in CP we given the actual array, and we give the two variables in the swipe is j plus 1. ये हुआ ना, ये हुआ ना सही से. Here, this is the garbage, right? Yeah, this makes sense. Int comp is int star array, um, int I, int j, something like that. Return array I minus array j, and we can do something like int swipe int star array, and because we know that is the case, we can do something like right. So int comp takes an int star array and two index, and pretty much just cares this if I is greater than j, right? If array I is greater than j, this will be a positive result. If they're equal 0, nothing, then that is great. And then we make this bubble sort function, right, which is a bubble sort which takes in void star array of any type, takes the length of it, um, um, what do you call it, CP, okay, comp, and then swipe sf. Okay, so for int I is equal to 0, I less than length I plus plus, for int j is equal to 0, or j is equal to 0, j less than I, so I think len minus 1 minus n, len minus I minus 1, j plus plus, right? Yeah, I think I remember that is how the code went. Right, and what we will do is we'll call the conf cp function, and we'll say right, start array, 0, because we know that this returns an int, and um, and we will essentially do something like okay, um, comp function one is in just this seems so messy, bunch of yeah, so that's a bunch of mistakes, that's the word I got. And let's see if this works. Um, okay, that works. So let's see what this happens. So we have a generic which takes in a generic void star. Makes sense. So the reason why it's able to dereference the void pointer is because the moment we call int com, it actually just typecasts it to int. So now the compiler knows how many bytes to see. Okay. Yeah, I guess the most next step would be something like int float um, ठीक है of that works. Okay, makes sense. The above functions clearly define how to compare and swipe two elements in an integer array. How do we use these functions in a bubble sort? We can define an array of ints and simply call the bubble sort as following. By the way, I hate when someone does this, like, because I now have to basically count this. Now I know what you guys will be saying. Oh well, Natik, you could simply do something like size of I said what was it? What was it? Size of a का 0 the size of a entirely, right? I mean, if I know that, if I think it will give us, like, especially for this, if I do something like, let me do something like this, because I know that's one of the things that you do. We could do something like size of array by size of array by 0, I think. 5. Yeah, so you could do that, but come on, man. But you do realize that you can only do this if the array is defined within the scope you're working with, because if that array is being passed as a pointer, then you don't have access to that, because it will be just passed, it will decay to a pointer. I don't know if you guys know this, but whenever you pass an array into a function, it essentially decays as a pointer, right? Some of those things about C that's quite interesting. The technique can be used to write any function for any array of any type. We only need to write an algorithm once it's in the proper function. So yeah, so it's upon the programmer to provide the correct comp and swipe function, because that is what we as the function writers are defining on. Okay. Questions. Anana Gunwarda. Who is this teacher? Chat. Let's find this teacher. How do I close this? Let's find Anana. Who is this? Oh, he's a teacher. Assistant. Oh wow, that's crazy. Wow. Wait, he's in Princeton also? What the hell? So he's a computer science. Oh wow. Oh wow, he's at Princeton. Oh my god. Wow, crazy. You. Oh my god, he was there from July 1998. Wow. And abhi tak hai. And now he became the Princeton University. Wow, yeah. Congrats, yeah. Crazy. Crazy chat. Crazy. Crazy teachers, yeah. Nice talk by the way, sir. Anand sir, nice talk. Appreciate it. Let's read through this. Define two functions, string comp and string swipe, that compares two strings based on just their first characters and swipe the entire string. Show how you call the two functions to sort an array of strings using generic purpose sort. Array of strings. Write a function array apply that takes a generic array and an operator and apply the operator to each cell in the array. For example, suppose the array is this and the operator is square and the resulting array would be this. Oh wow, okay, so I think we can do this. So write a function called array apply. So we have a function called void array apply. You know what? Actually, let's be grateful about sir. Let's send him a connection request, right? And if he accepts it, chat, we will just say thank you so much for writing the innocence. Wait, David, thank you so much for writing the this. We'll just tell him thank you so much. And resulting array would be this. Okay, so array apply takes in a random array we don't really care about. Suppose array and operations. Now the question is, what should be the definition of the operator? So void. Um, operate func. What should it do? Hmm? What should it do? Also, it should take the length of the array, right? Int length. Also, right. Operate func. I think this makes sense if we do void star int. Let's see with that. And what we will do is we'll make a func which does void. To be honest, this and this is quite same. I'm just doing it for naming purposes. The difference. So this is operate func, and so I'll say operate int. So pretty much let's say square. Okay. So I take square int star array and takes an index and essentially does right. And over here we would take OPF I guess that would be fine. So we would do something like for int I is equal to 0, I less than length I plus plus. Um, um, this should work, right? Let's clear all this thing. Let's do array apply this and the address of square, right? Okay, this runs. So if I do it actually did work. That's actually crazy. Yeah, so we were able to do this, I guess. Great. Write a function in find pause. Write a function in, so this is the function. So the function is int pause, which takes an array of some type, and this is length, and f type fp, where a is a generic array of size n, and ft is a function pointer that takes in an array and size as its argument and apply that. This is so vague, sir. What do you mean by this? So, I mean, I understood one thing is key. This is our actual function that we are writing. Okay. A is a generic array of size n. F type is a function pointer that takes in an array. So it takes in an array. So void star and size F type. Okay. But what does it return? And apply the algorithm to find the position based on the function. I don't- Okay, I don't understand that. Like, this is confusing. What do you mean by that? Define two functions, string comp and string swipe, that compares two strings based on their first characters. We have it. Yeah, so it's pretty much this. Where is string func? Removed it. Yeah, his example was this, which is fine, but this doesn't match our definition of the way we made the comp function to be like. that's the thing, right? You can't really do this. Um, can you do it? This is fun, cool. I think we'll end a bit, but let's just read this. Right, this is a bit fun. The clockwise slash spiral rule. I thought this was fun. I mean, if we were to look at C code, then why run away from it, right? So there's a technique known as clockwise slash spiral rule, which enables any C programmer to parse in their head any C declaration. Bold statement, chat. There are three simple steps to follow. Starting with the unknown element. So three steps, by the way. Start with the unknown element, move in a spiral clockwise direction. When encountering the following elements, replace them with the corresponding English statement. So if you look at this, we'll say, well, it's array x size of, or array undefined size of type 1, type 2, function passing type 1 and type 2, returning something star pointers to. Interesting. Okay, so stars mean pointers to. Keep doing this in a spiral slash clockwise direction until all tokens have been covered. I feel like I'm a tokenizer. Always resolve anything in parentheses first. So let's start over here. So the first statement we have is this statement. Now, me knowing C, I can tell you that this is pretty much an array of like 10 characters max to max you can put. So, okay, let's read this. Question we ask ourselves, what is stir? So we start from the sir. Well, stir is an array 10 of pointers to characters. Okay, so okay, pointer to function declarations. Okay, so what is FP? So FP, so okay, so FP is a pointer passing an int and a pointer to float. Okay, so FP is a pointer to a function passing an int and a pointer to float, returning a pointer to a char. Okay, what this means to say is FP is a function pointer pointing to a function that takes int and float star and returns char star. Right? That's exactly what it is. The ultimate. Bhai sahab. Okay, so I know what this is. Oh, bhai, this is cruel, bro. Because if you see this carefully, if you see this very carefully, signal is a function pointer. Um, okay, I think this is a. I think this is a. Okay, I think this is a function call, a function definition. So we have a function called signal, which will return us, which will return us a function pointer that takes int as an argument and returns a void, while the function itself takes an int and also a function pointer of this type. Signal is a so signal is a function passing an int and a pointer to a function passing an int returning nothing. Okay, yeah, that makes sense. So basically, it takes a pointer to a function that takes int and returns nothing. Um, Returning a pointer to a function. So okay, so yeah, but then it itself will return a function pointer that gives takes in. Okay, so I think this might be the guy. This might be the guy. Interesting. Let me launch that generic video type video right now. Just give me a moment. Back. So yeah, this was the video that I was watching before this, right? Okay, let's look
Notice
at
that the
this.
C standard library actually uses void pointers everywhere in order to give us a type agnostic API.
Okay, let's look at some of them. So yeah, this looks like binary search. This which returns void star itself. I think this is length. What is this?
So what we're going to do is essentially use this technique ourselves on our own personal libraries and data structures that we want to build. To demo this technique to you, I've got two elementary data structures. The first one is a linked list. Now let's look at our implementation versus the ones from Google. You'll notice that the data type that I've specified in my linked list node is not an integer, it's a void pointer. And what I've actually got down here is a struct that represents the state of the linked list itself. Why do we need a state struct all of a sudden? Well, here's the trick. What you need to think about when you're designing a type agnostic library, you need to know everything you can about that unknown data type except for the type itself, because that's the thing that the compiler is going to bite you on. So in terms of a data structure, what we need to do is we need to know the size of the data, and that's what we collect here in the metadata for this struct. So the user of the API can provide the size of the data. And this is common across other functions, like if you use memcopy and stuff like that. They all need to know the size of the data that they're operating on, but they don't necessarily care about the data itself. Now, with a linked list, it gets a little bit more interesting because sometimes we do want to care about the data itself. For example, how are we going to walk our linked list and search for a value? Well, that's where the magic of function
Yeah,
pointers
so this
comes
is
in.
exactly what we learned. So the same thing could be applied in some sort of way in binary sort. If you don't know the data type, any data type that you don't know can have a different understanding of how it's compared, right? So that's why we have a proper, comp func for that and a swipe func for that, so that we can essentially just compare it without having to worry about the actual intricacies of the function, because we put that operation onto the user. Yeah, the user will worry about it, not us, right? So that is essentially what that is about.
In where you pair it with a void pointer. And this is a technique that's used, for example, in the
Okay, so over here, this is essentially a match is essentially a function pointer, which points to a function that takes void star const, and will return a bool itself.
the C standard library binary search implementation.
So this is binary search. So again, this I don't know. Okay, so this is very interesting. Look at over here. So we have a compare function. So compare is a function pointer that points to a function that takes two arguments, which is of type this, and returns int. I'm assuming int means 1 if it's greater than the one first element, I think. So this is, I think, the length, size. Okay.
Which is where you simply provide a compare or matching function, which is user specified. So when you initialize this linked list, the user can provide a matching function.
Yeah, that's true. But then again, the comp func has to be very much flexible in that sense, right? You need to be in a very flexible position to be able to do that. Because right now, some comp func may not align to this function prototype, so that could be an issue.
That takes in data structure 1, data structure 2, and compares the two to see if they match. So for example, if you define a struct, and I've got one over here. So what we're going to be testing this linked list with is my wicked data structure. And my wicked data structure has a key and a value. And I've got two examples of match functions here that we could give to our linked list search. The first one is just based on the key comparison, which is the integer. And so, for example, what you do with the wicked match is you take in your void pointers, because obviously that's what we need to do, and you cast that.
Yeah, you have to cast it because you're dereferencing it to get the key type, and as you know, you can't dereference a void pointer unless you typecast it, so the compiler knows where to look for it.
or proper data structure type. And once you've casted it, you can actually access the struct.
It's a funny thing I want to do. Let's say I have a float x which is of some value this, and let's say I go void star p is equal to this. This is completely fine and this works, right? If I do print f, um, mm, okay, what my real understanding is now that's a funny thing. Let's typecast this and then dereference. Okay. So let's run this. Actually, again, this is bad because then it would be. Ah, yeah, that's the thing. Dekho, you see the issue, right? Because now, so let's see if it's working properly or not. Again, one more thing, I'm just dumb. This is CIF. It don't really matter about that. It tells us the right part. This is 1324. Again, I don't know why. I mean, just dereferencing it essentially. But if I dereference this to an int, and the other thing, if I do that, if I do I, then it might give me some random idea, which this is this and that two different things. So that typecasting has to be right unless or the compiler will start seeing something.
And that is the trick that lets the compiler be happy with you. It's essentially like at compile time, everything that needs to use that data still knows what the type is because you do the cast. And to be fair, you do rely on the user to be accurate with their APIs and their initialization and everything, but the data structure library does not care about the underlying data because it never has to use it. What it's going to do is reach out to a user-specified function which does know what the type is. And that's kind of the whole trick here. And so when you come across complete vibe-coded slop, like the Zero Lang repository from Vercel Labs, which has a lot of C that I've had a little bit of a look through, and you come across something like this, which is where they've got a function vec type and a shape vec type, which are identical except the pointer that it stores, you can know that
Which
there's
they
a
could
much
have.
better way to do that if you weren't completely vibe coding it using AI. 4.1k GitHub stars, by the way. Now, how does our library actually work with the void pointers? It's cool that we can write that in our node over here, but when it comes time to actually insert that into our linked list, how does that actually work? We come over here to this ll insert function.
Okay, so let's look at this. So we have ll insert, which can return ll error, which I'm assuming is some type def. LLT. Again, I don't know why. What's the reason behind this const star, but star const, but yeah, fine.
What we're going to do is alloc the node container, which is this whole container here. And then if you come over to this section, this is where we actually work with it. I've got an option here, which is BYOM. That's bring your own memory. So when we're writing a data structure like this, typically I like to code for two scenarios. The first scenario is where the calling function or the caller is going to own the memory that that element is stored in, and we're just going to copy a reference to that. And so what this allows the caller to do is hold that struct in a buffer somewhere if you want to pre-allocate all of this memory, and simply pass the pointer to that. And the pointer is what's stored here. And so it's the caller's responsibility to clean that memory up. You can also do basically a copy container, which is where you malloc a data, the size of the data, and you simply memcopy that data in. And because memcopy is working with void pointers, and we don't actually care what the underlying data is, it's just all bytes, and I've done a video on how everything is just bytes that you can check out as well, this works perfectly fine, and we never have to inspect the type of the data that's being passed in. Now for a little demo about how this is going to work. So what you can see here is I've got my wicked data structure, and basically what I'm going to do is just loop through to 25 and insert. Why can I not individually address the 8 bytes that make up this pointer? Well, as it turns out, you can. So what we're going to do next is cast our struct into a byte buffer
Yeah,
and actually
so
individually.
cool. I guess I have kind of kept this time to learn Go, even though I kind of like learning this.
insert 25 of them. It's got a key, it's got a value. The key is simply going to be I, which is the index of the loop, functions, helpers, anything. And if you want to be able to do that and use them in your projects,
I mean, I don't
be able to work with arbitrary data, but be aware of performance if every cycle counts. To demonstrate that I'm not a one-trick pony and that this technique is generalizable, here's a ring buffer implementation. Now, this is still fairly simple. It's about 140 lines of code. And if you come over here to the state struct, you'll notice a couple of familiar things from our linked list.
I'm gonna leave this for now. Even though I want to watch this,
we've got a matching function
I
over
will
here, but we've
keep
baked in
this.
some ring buffer specifics. So for example,
Cool, chat. So I'm gonna open up Golang real quick, and I mean I did like writing all of this code. It's kind of fun. So I'm gonna open up Golang and then we'll learn Golang. See you in a bit. We're back. So I was just reading through this. The majority of software engineers view Go as an exceptional, efficient for backend and cloud development, though it is frequently draws criticism for rigid simplicity and boilerplate syntax, according to Go Developer overall. Oh wow, Go Developer Survey. No upgrade hill. Yeah, that is kind of true. Developer's opinion on Python. Um, Self-identified. Um, I mean, how did I, yeah, I mean, wow, crazy, interesting. Anyhow, that is fine. I was about to experience. Right now, I was typing. Anyhow, but we were over here. We're learning about types and all. Let me just revise it real quickly because I don't want to be lost. Yeah, so essentially these are pointing to ints. This is pointing, essentially this is an int star. Okay, point is done. Structs, type def structs, we can initialize them. Then change the values. Cool. Um, we can have a pointer to that, and then cool. Struct literals. So instead of doing that, you can just do a bunch of that, and this kind of works, which is interesting because I would assume I would have something like text, some sort like that. You guys got a type can be omitted. You guys need to work on your in a sense optimization of the ID. It's way too glitchy for my laptop. I'm arrays. So int t is an array of n values. Type t. Slices an array has fixed length. A slice on the other hand is, yeah. So this is essentially saying you can bring in a slice from another. And if I run this code, how do I run this code? Okay, let's run this code. Will it pop up the terminal on its own, or will I have to um, compiling? Take your time, man. Take your time. क्या हो रहा है? कहाँ पे हो रहा है? Uh, what? Um, okay, something like dot add. What is it? Append. Yeah, append. Oh no, 15, I guess. 17, yeah. What's the issue? Uh, okay, issue क्या है? Is it a runtime error? Append. What? आप ही तो दिए थे मुझे ऑप्शन. Anyhow. क्या हुआ? Compilation fail. Thank you. Oh, interesting. So it's not 0. What is this? कुछ update आया है? Oh no, खाना भी नहीं करना. I'm not even looking at the code. So sorry. I was so busy looking at this. Okay. I'm just tired. Can something like like we do in C. Oh, you can't. It's D. So it's pretty much like enumerate. So for IDX, it's pretty much like val. Pretty much. So this will be the IDX, and this will be the val essentially. Real world P. So what is this? Range. Go run task. And again, to show you that this works, if I do this right, it will still work. Yeah, that's pretty much works for any data type. Yeah, this is pretty much like enumerate, if this is like similar to that. Yeah, and this is essentially just like getting that value. Much very this I like this. I like this. Range continued. You can skip the index value. Okay. Hmm. Okay. ठीक है. I mean, it's not like you can't access it, can't you? I can still say something like this. I can't. Oh wow. Hmm. Interesting. So in Python, that's just taken as like taken as a suggestion. But over here, it can't. I think you can though, right? If I'm correct, like if I do Python compiler online, um, and let's do something very simple. So we can do something like for I can do something like this because Python doesn't really care about it. It just says, oh, well, you guys are consulting adults and you allow that. Yeah, pretty much that is allowed. And so we have POW, which essentially makes, I think this is pretty much equivalent to dynamically allocating an array of size 10, of length 10, because if we specify the capacity, then we can do that. As you see in make type size, okay, exercise. क्या है भाई ये? So one thing I can understand is we are taking dx and dy, which are integers. We're returning a two-dimensional array of u ins 8. Okay. Implement pick. It should return a slice of length dy, each element of which is a slice of dx. इससे तो साइज बढ़ रहा है. क्लिक द डिपेंडेंसी. कहाँ कहाँ? हाँ, क्या है इसमें प्रॉब्लम क्या है? अरे भाई टेंशन मत लो, डराओ मत. नोट इफ द डिपेंडेंसी क्लिक द डिपेंडेंसी. क्या क्लिक कर चुका हूँ, क्या करूँ? प्रेस कंट्रोल. अरे भाई कहाँ? आ, क्या क्या करने वाले क्या हो तुम? What are we doing? I'm so tired. What was that? Uh, okay. Implement pick. It should return a slice of length dy. I mean, वो तो बना ही सकते हैं ना हम लोग. Because we have seen we can easily just do this. So we could say something like can say pick of uint 8 of dy essentially. क्या इशू प्रॉब्लम क्या है? Unused variable pick. ठीक है ना भाई, 2 मिनट. um, Implement pick. It should return it should wait a minute, I'm assuming. भाई तू 2D array पढ़ाया नहीं है. This is like my college exam. They don't teach something. They'll um I think I need to do something like this. Oh no man, this doesn't make sense to be honest with you. Like If I just do return pick, right? Yeah, my bad. Pick slice, pick slice. Okay. Abe, yaar, you will, bro. You are dictating everything of my life. Please go MF. Please, I'm so sorry. They're like the Go FMT will spank you, bro, if you do anything bad. Okay. Okay, let me just search this up. 2D slices in Go. This. Um, mm, 2D slices in Golang syntax. This is developer experience 101. In Go, a 2D slice is implemented as slice of slice with the syntax this. So, भाई क्या कर रहा हूँ? हाँ, make yes. Allocate. Okay, so it's pretty much like oh, okay, so this is the rows. Allocate the rows. So okay, it's pretty much like C. So it's like okay, ठीक है, we will make bunch of these rows. Okay, these a bunch of slices, but इनका खुद के अंदर एक slice है. Okay, and then we loop and allocate each inner slice. Okay, I think we can do that. Each element of which is slice of dx. What do you mean? Which is a slice of dx, 8-bit unsigned integer. When you run the program, it will display your picture. Interpret the integers each. What do you mean? What do you mean it's slice of dx? भाई, what do you mean? क्या बोलना चाह रहे हो? क्या हो रहा है? Okay, we do for I range of pick slice. So pick. I think pick grid makes sense. Yeah, I like pick grid. Pick grid. Let's go. Pick grid. Um, we'll say I is equal to make u int 8 u int 8 of dx. मैं खाली यही लिख देता हूँ भाई मुझे. It's saying each element of which it should return a slice of length dy. क्या बोल रहे हो तुम? What are you saying? क्या गलती क्या है इसमें? प्रॉब्लम क्या है? What is the problem? What is the problem? Unresolved pick slice कहाँ पे? कहाँ पे pick slice? कहाँ पे pick slice? कहाँ पे? दिखा दो pick slice मुझे. um ओके, सो ये एक भाई, तो इसका मतलब क्या है? What am I doing? um Wait a minute, I think I know what to do. So we essentially just okay, कुछ वाई वाई का वैल्यू है, ठीक है. Okay, and then यहाँ पे एक another is a slice we have allocated of length x. This length x that doesn't even make sense. सब खाली रहेगा. What, bro? These aren't questions are what, man? Okay, this is correct. Okay, even this is correct. Wow, then what are they doing different? ये तक यहाँ तक तो सेम ही था हम लोग का. ठीक है, तो ये लोग बना दिए. एंड देन फॉर y slash row, so this is essentially the index and the value range of p. Wait a minute. Okay. Okay, this will work because right now it just contains like null values, so this will essentially just work. So now what this will do is we do for y range of big grid. Okay. Um, big grid, and then we will say um, what is this doing? So we essentially just, so we have a bunch of indexes over here. So we are essentially going into this one row के में, and we just take its index. यहाँ पे we take this, we call this as this. I'll just call this as idx, and we'll say row idx is equal to u in 8 x into y, right? I think dx into dy, some shit like that, right? Does that work? कंपाइलेशन ही फेल हो गया. अरे बाप रे बाप, कंपाइलेशन फेल हो गया. क्रेजी, व्हाट अ लूजर. एक्चुअली ये आई डोंट नीड दिस. हाँ भाई, मैं क्या करूँ, मैं जान दे दूँ क्या? क्या ही हो रहा है इधर क्वेश्चन में. सो वी मेक दिस. ओके. ओके, सो व्हाट इट्स डूइंग इज, वो उसका y का वैल्यू लिया, वहाँ का x का वैल्यू लिया, राइट? सो दिस इज y, एंड इसके अंदर x का वैल्यू है, उसको इसने मल्टीप्लाई किया. ओके. X essentially, because that's already in there, and makes sense. So essentially what this guy did is he made a grid of y rows and x columns, and हर ग्रिड का जो x का वैल्यू है और into y के वैल्यू में उसके अंदर घुसा दिया. And the way he did this is first he make the big grid of only that y, and फिर it allocated. So first of all यहाँ पे uh, allocated all allocated dy number of rows, allocating dx number of columns inside each row, and then we say okay, well, y आपका index होगा and row is your value, but row itself is a slice which we can use the range command. So now we have x is the index of each of the elements, so now we can essentially do row of x is equal to that. Crazy. Okay, by the way, these questions are horrendous. Like, this could have been such a better way of writing this. This could have been such a better way of writing this, but chalo theek hai yaar, I am a dumb. um cool. Maps, we talk about range tha na ye. Okay, a new maps keys to values. Horrendous grammar. A zero value of map is nil, a nil map has no keys. Okay, this is dictionary, right? This is dictionary. Okay, a map function returns map of the given. Okay, this is like hash maps. So we have a type vertex with lat and long of float 64, and then we have a var of map. So I'm assuming this means key it takes the string as a key and value. This is m. Okay, so m is a m m is a map. Okay, and then we say make map of this, and then we put this. Okay, this is essentially an hash map, right? Maps in Go are pretty much hash map. Okay, they behave like Go's. So it's essentially an hash map. It's essentially an hash map. I mean, sure, I can run it. Let's go cd this, cd maps, go run. I wonder if I could just make it directly like this, like I could say some type of, like, is this even needed? And do something like, no usage, put this, can this be running like this? Yeah, actually, because this itself gives the information, right? Matlab, why do I need to do that? This itself gives me the information. Map literals. Map literals like struct literals, but the keys are required. This is this. I want to see how it works, right? So this, go run tasks. Go. Okay. Map literals continue. If the top level type is just a type name, we can. What does this mean? इससे पहले डिफरेंस क्या था? Okay. Mutating maps. Inserting updating element in a map is M key. This is pretty much like Python. Retrieve an element. Yeah, Python. Delete an element. Map and key. Which is null. I'm kinda starting to like Go. Like, to be honest, I'm kinda starting to like Go. Again, why are you doing this? Mutating maps. Sorry. Go run task.go. It's 0. Okay. Exercise maps. Oh, exercise maps. Okay, we have exercise chat. Again, ये अभी तक, अब इसको मैं टाइडी करूँगा, रोऊंगा भगवान से ही ठीक हो जाए. Okay, implement word count. It should return. Okay, so this is word count which takes in a string, maps string to an int. Okay, it should return the map counts of each word in a string s. The wct.test function runs a test suite against the provided function and prevents success. You might find string find. Um, so, um, string. I loop over it though? Like, can I, in a sense, loop over it? And I don't know, like, um, what I mean to say is kind of something like void. Okay, hell with that. Let's do something like this. Actually, we just read that. Okay, that's clearly not void. Let's leave that. Let's say something like we have hello world. Um, uh, can I do something like for words range string fields s fmt dot println. I'm still not that confident writing Go code, to be very much honest with you. Um, okay. I have to do that. But, I got excited a little bit. Um, formats specifier for strings in Go. But this is, I think, IDX words. हाँ गलत कर रहा हूँ क्या? Okay, wait a minute, chat. Exercise है ना यहाँ पे? Yeah. Can I make a new folder over here? New Go file. Okay. Thing like take this code and how do we do that? सब साथ में मिला के fmt and do strings. ठीक है? हट मत हटा भाई, हटा दिया? अबे wait कर done. Okay, no worries, let's do something like fmt. Okay, that's unused. Okay, no worries. Let's go something like func main. We go fmt dot print and then hello world, and let's remove that. Let's remove that. There's so many mistakes over here that I'm trying to cry my hearts out. CD exercise map. Yeah. No, back this CD exercise. CD exercise. This go run exe.co. मजा आ गया. Hello world, great. Now if we have like an s, hello world, right? What I could do was this. I could do something like for word is equal to range of strings dot split s, and I can just say that say issue क्या बात कर रहे हो sorry fields, my bad. And then I can do fmt dot print ln word. Okay chat, if this works I'll be very happy. Again, why is this printing? Why is this printing? What is that about? Okay, I don't need the double though, so. Okay, so we found a way to do that, which is great. Okay, show me. Also, भाई इससे पहले वाला कहाँ गया? Keep this open in the background, please. Okay. How do I just make it? Okay. ठीक है. Right, so we can have something like word count map. ठीक है. Rename usage. क्या करूँ मैं? You can't do anything. What's the issue? It's unused. Bro, this is so annoying. This is so annoying. Anyhow, this is legit so annoying. Can't. Okay, anyhow. And obviously we have to import that word. Okay. Strings dot field s. Yeah, let's just do something like please, and we'll do return word count map. Okay. What do you mean? It's not fields or what? It's sorry. How to check if a key, oh yeah, pry key is in map or not in Go. Okay, so we do something like valve okay is equal to word count map with the key of word, right? So if okay, else this exactly. So if the key exists, then we would do word count map. For that word we would choose 2 plus 1 plus plus, right? What's the issue? What? My bad. Else word count map word make this set to 1. Okay, yeah. Okay, so I think this should work now. right? This should work. Can this work, please? Yes. Let's go. Man, this writing Go code makes me feel so smart though. Like, why can't I remove this comment? Figure this out. Let's go. GG. So, yeah, I think there's a better way of doing this, but sure, why not? Let's pick up the solution that the author has wrote. Ah, interesting. So this something. I think this is the shortcut for that. But anyhow, yeah. Okay, guys, I'm gonna end it now. Even though it's getting even fun, we solve a first question by ourselves. But I'm gonna end it now because I'm very tired again. Yeah, but yeah, it was fun. We learned C function pointer. We were able to play around with it. Very fun. We'll do more of it. And yeah, more of Go as promised. See you later.